All right, moving on to example 3. This one's going to be a little more challenging, and you're going to see why in just a moment. First of all, obviously there's an x squared in it. That obviously makes it harder, right? But the other thing that makes it harder, the real thing that makes it harder is this. You got a minus 3. If I slide that over, notice I'm going to get the square root of all this stuff. X squared plus 2x plus 13. Don't focus on what's underneath the square root. Just know I need to get the square root by itself. So the square root's by itself. It doesn't matter what's the square root of. Get it by itself equals. Then I have x plus 3. What makes it harder is the fact this x and this 3 can't add together to make one simple little number there, right? Instead I have a binomial expression on the right-hand side. So again, going to my technique which says if a is equal to b, then a squared equals b squared, right? B this time is represented as a binomial. So when I square both sides, I'm squaring the left-hand side squared. The right-hand side is the binomial squared. Be careful that you square that binomial properly. What I mean by that is that we square the first object, we square the last object, and we double the product of the two objects. This middle term here gets left out quite often when we do this. So be careful. We're squaring a binomial. Keep in mind that comes from the fact that x plus 3 squared means this. X times x is f, and 3 times 3 is L of FOIL, right? The middle term is made by the O and the I part of FOIL. 3x and 3x. Notice it's 3 times x twice, so 2 times 3x. That's where it's coming from. Okay, so the O and the I part of FOIL is just the product of the two objects doubled, two of them. So 3x times 3x is 6x. That term's left off a lot of times by people. Be careful of it. I recommend getting comfortable with the shortcut, but know that FOIL is available too if you're not comfortable with the shortcut. Just write out what it really means over here, work it out. There's x squared, there's 9, there's 3x and 3x. You get the same expression. But again, this happens hundreds of times. Binomial squared. Get comfortable with the shortcut. You're going to save yourselves time. The left-hand side, again, it doesn't matter what's inside the square root. If you have a square root and you're squaring it, you get the contents of the radical. So x squared plus 2x plus 13 is what we get out of that side. Now what's nice about this one, they did for us, sometimes they're nice in the book, is there's an x squared on the left and an x squared on the right. If I move one to the other side, it changes signs, right? So they're going to cancel out.
Really?
Yep. So if I just move that, it becomes negative x squared, becomes 0, right? So since they're exactly the same thing on both sides, you can just strike them out. The remaining equation is just a basic 2x plus 13 equals 6x plus 9. I would probably move the 9 to the left and the 2x to the right. You can also move 6x left and 13 right, take your pick, but just as long as x and numbers are on opposite sides. 13 minus 9 equals 4, 6x minus 2x is 4x. We divide and we get an x equals 1, which is a nice friendly answer to a pretty ugly problem. Again, that represents the candidate for the right answer. It's not necessarily the right answer. So what I have to do at this point is change each x, this one, and this one, and this one, all to the number 1. Verify that it actually works. So looking at the square root expression here, I'm going to get the square root of 1 squared is 1, plus 2 times 1 is 2, plus 13. Okay, when I substitute my number in, I go ahead and square it, multiply it and stuff as I'm putting it in. If you feel more comfortable going 1 squared plus 2 times 1 plus 13, that's fine, but 1 squared is 1 and 2 times 1 is 2, so that's where I'm at. Then I got minus 3 outside the radical, and it's supposed to equal x, and again, x is supposed to be 1, right?
Yep.
So again, I just substituted 1 for all the x's, and I got my expression here. If I simplify it out, 1, 2, and 13 all underneath the radical add up to 16. The square root of 16 is 4. 4 minus 3 equals 1 is a true statement, which means our candidate for answer gets elected. So x equals 1 is the correct answer, and that's the end of that problem.